Hello everyone. Today I'm going to talk about two words that in every chemistry class, if anyone has ever taken chemistry, when they hear these words, they cringe, and it's called significant figures. See, I said it and you probably just cringed. Significant figures, it's not hard to figure out, but there's one number that gives a ton of headache to, and it's the number 0. Sometimes it means something to us in chemistry, and sometimes it isn't. So we call it significant. So before we look at the rules, and then we'll do some examples. In another video, I'm going to show you how to do calculations with significant figures. So in this video today, I'm just going to go over the rules first. So there are 5 rules that I usually do with my students, and I'm going to break it down. Rule number 1 is very simple. Basically, any number that's not 0 is significant. So we call it a non-zero integer. So as you see the 2 examples, I don't see any zeros, so every number that you see in those 2 examples are significant. It's where that 0 is placed. Is it before the number? Is it in between numbers? Or is it at the very end of numbers? It actually does matter where that 0 is placed. So the second rule, and for the rest of the rules, it's all about the number 0. So here we go. Rule number 2, leading zeros. These are zeros that start before all non-zero digits and are never counted as significant. And they're not counted as significant, but they actually mean something to the world because they're called placeholders. So if I had a number 0.0003, those zeros are not significant because they lead it, and I haven't hit not one non-zero digit until the very end. So I only see one significant figure. And that one significant figure I see is right there. Now that doesn't mean that I'm going to get rid of those zeros, because when you see a number 0.0003 versus just saying 3, that's a huge difference. I mean, you're talking about something that's a factor of times 10, times 20, times 30, I'm sorry, times 10, times 100, times 1,000, times 10,000. Every time you move the decimal, it's a factor of 10. So you're talking about a number, this number versus 3, it's a difference of 10,000. It's a huge difference, okay? So if I had a number, the next example on here, 0.000456, these zeros do not mean anything. Doesn't mean I'm going to get rid of them, but they're placeholders. So the only 3 significant figures I see is 4, 5, and 6. Same thing with this one. Leading zeros mean nothing, so the only sig figs I see is 2 sig figs. And obviously we saw a video, if you have not yet, about scientific notation. We would never write a number this big. I usually tell my students the rule of 3. As long as there's not more than 3 zeros, then you don't have to go scientific notation. Something like this, we would definitely go scientific notation. But all of these zeros are just placeholders. So the only 2 significant figures I see are at the very end, that 5, 2. So what happens if the zero's in between actual sig figs? Well, now that 0 counts. So we like to call those captive zeros. So any zeros that fall between non-zero digits, so any digits between 1 and 9, that 0 now is significant. So right here, obviously the 1, the 4, and the 5 are significant because they're non-zero digits. But because these zeros are between the 1 and the 4, they are significant. And this 0 between the 4 and the 5 is a captive also 0, so that means you have 6 sig figs. This number right here, 5004, both of these zeros are between that 5 and that 4, so they do count as significant. So I see 4 sig figs. 602, same thing. I do see that 0 is between the 6 and the 2, and it is definitely significant. So I see 3 sig figs. And even if we had a number like this, now obviously I'd be going scientific notation. Even though these zeros would be a pain to write out, you could write a number like this, or obviously scientific notation. But all of these zeros matter. They are significant because all of those zeros are between the 6 and the 2. Now you're trying to probably think of a question right now. If the zeros in the front don't matter, they're not significant. The zeros in between matter. But what about the 0 at the end? Well, that's the trickiest rule of all. It's that trailing 0. If that 0 is at the very end of the number and you have a decimal, but that decimal's in a certain spot, that 0 can actually be significant. And I threw a little bit more examples on this one, so that way you can see the difference with that decimal. So just because you see a decimal and zeros doesn't mean it counts, because it depends on where that decimal is and where those zeros are. And I know you're like, oh my goodness, it's going to be a tricky rule, but it is. So if I had a number 1000.0, well, every single 0 after that 1 matters because of this right here. Those zeros are only significant if after written, if they're for those zeros at the end of a number, and I see my number 1 right there, and it's written after that decimal place. Okay, so I see the 1 and all the zeros after the 1 with the decimal. Every single one of those counts. So I see 5 significant figures. 5.640, obviously the 5, 6, and 4 count, but does that 0 count? Well, it does, because not only is it after a 4, but it also contains a decimal. So it doesn't have to be after the decimal, okay, necessarily. It just has to be after an actual, real, significant figure number and contain a decimal, okay? So I have 4 sig figs here. 1, 2 with 4 zeros right there, so 120,000. I see a 1 and a 2 and a whole lot of zeros. Now, because the zeros are after the 1 and the 2, they now make them significant because I see a decimal. I could have put that decimal here. I could have put it here, or here, or here, or here, or here, and they all are significant. I could have wrote this number 6 different ways, and it still makes them all significant because those zeros are after the 1 and the 2. So I see 6 sig figs. But what if it doesn't contain a decimal? So what if I took the same number and just took away the decimal? Then they're not significant, because the rule is it has to follow non-zero integers and contain a decimal. No decimal, no dice. So the only sig figs I see is the 1 and the 2. So I only see 2 sig figs. Okay? But now let's throw in 2 rules at once. What if you have beginning zeros, which remember we called these leading zeros, but now I have a 0 at the end, and that's called the trailing 0. Well, do these zeros in the front count, and does a 0 in the back count? And I'll give you a hint, only one of those zeros do count, and it's that one right there. These zeros in the front are not significant, they're placeholders, so I do not count them as sig figs, but the 1 and the 2 are significant, and the 0 after the 1 and the 2 is significant because it also contains a decimal. I could continue putting more and more zeros after it, even if I wanted to take this number and maybe put a 0 in between the 1 and the 2 and keep the 0 there. That 0 is significant, and that 0 is significant. Sorry, it probably looks more like a 6. Let me write that again. 0.001020. So that 0 is significant because it's between the 1 and the 2. And this 0 is significant because it's after the 2 and they contain a decimal. So in this case, I would have 4 significant figures. In this case, I have 3. Okay? Let's try a couple of these. In scientific notation, my very last rule before we start practicing, students get a little confused about that times 10 because, like I said, they think that means 10 zeros or 3 zeros or 5 zeros, and it means you move the decimal that many places. So this number right here, we do not even need to look at this part of it to figure out significant figures. Now, moving a decimal, absolutely it matters, but for figuring out sig figs, it doesn't matter to us. So if I have 1.00, I see 3 sig figs because the zeros are placed after the 1 and it contains a decimal. 5.640, okay, so right there, I think we saw this number in an example before, but just because it's in scientific notation, it doesn't mean anything to us when it comes to figuring out sig figs. So that 0 matters because it's after the 5, 6, and 4, or just plainly it's just after the 4, and it contains a decimal, okay? So as you see right here, some examples. Now, if you want to pause the video, try it first, and then unpause it and check your work. Okay, so let's go through this. 23, very simple. I see 2 sig figs. 1.498, same thing, very simple. The ones without the zeros, pretty easy. Now what about letter C? It starts with a 0. Well, that's a leading 0. It's not significant. So the only sig figs I see is right there, the 238. So I'm going to say that's 3 sig figs. That 0 for letter D is a captive 0, so it is significant. So every single one of those values, it does matter, so they are significant. Letter E is like letter C. These beginning zeros are not significant, but the 5587 is. So that's 4 significant figures. Letter F, the 0 is between the 8 and the 9, so it is a captive 0, so it is significant. So I see 5 sig figs. And same thing for letter G. Every number is significant, even the 0, because it's between the 1 and the 7. So I see 6. Letter H, I have zeros that start out my values, so those are placeholders, not significant, but the 489 is. And when I go over examples with these with my students, this is how I teach them in the beginning. I tell them to underline, so that way I can see what they actually figure is significant and which ones that they don't think is significant. So that way I can see if they're getting this or maybe missing a concept or two, but it does help in the beginning. Now letter I have 3,000 with a decimal. Now the question is, do these zeros, are they significant? And those zeros are significant because 2 rules. Number 1, they're all after the 3, and there is a decimal somewhere. Okay, so I do see 4 significant figures. Okay. Letter J, that 0 is significant because it follows the 8, and there is a decimal. So I do see 5 significant figures. 307, okay, I see 3 sig figs. The 0 in the between it is a captive 0. And 4,500, question is, do those zeros at the end matter? And they do not. They're not significant, okay? And I apologize when I say not matter, because they do matter as in placeholders, but they're not significant, okay? So I only see 2 significant figures because those zeros, yes, they may be after the 5, but there is no decimal to make them significant. So I only see 2 sig figs. 350,000, same thing like letter L. I don't see a decimal, so my only sig figs are right there, the 3 and the 5. Letter N, I have 180.00. Now I see a decimal, and all of those zeros are after that 8, so every single one of those digits, they are significant. So I do see 5. 3.50, same thing like letter N. That 0 matters. It obviously matters. That 0 is significant because it's after that 5. So I do see 3. I got kind of 2 rules happening in letter P. I got captive zeros, and I have a trailing 0. So we already know captive zeros definitely are significant. But does a 0 at the end, is it significant? And yes, it is, because of it's after the 4, and I have a decimal. So I see 5 significant figures. Letter Q, I see only these 3 as my significant figures. The zeros in the front do not count as sig figs because they're leading zeros. And same thing with letter R. These zeros in the front are not significant. They're placeholders. They do matter, but not significant. The 0 at the end does count as a sig fig because it follows the 5, and it does contain a decimal. So I do see 3. Okay? So once you get the hang of sig figs, it's really going to help you when you come to calculations, which will be another video that I will show, because when you do calculations with sig figs, there's rules for adding and subtracting, rules for multiplying and dividing. Okay, so it's really important that you can figure out how many sig figs you see first before you start to practice calculations. So I hope this video helped, ladies and gentlemen, and I'll see you on the next one.